This is the third meeting for the open source VHDL group, and it's 18th of October, and we are going through a short agenda for today, some points from the official side, and then we are going to the OSVVM presentation held by Jim Lewis. So we have new people on the list. One is already online. It's Pete. Maybe Pete, you can say some words, what you are doing, how you came to VHDL, and yeah.
Okay, sure. My name is Pete Liddell. I've been doing VHDL-based development in the ASIC and FPGAs for about 20 years. First company I ever worked for did VHDL. Been using it ever since. So I'm heavily interested in the VHPI and using foreign languages with VHDL, something I came to love when I did a short stint with a company that did Verilog. So I'm really interested in leveraging foreign language interfaces in order to do verification, especially kind of complex, high-level test bench models and other features. So my interest is mostly on the verification side of things, since I think the synthesis stuff is already pretty well supported, and can't think of any corners that I could really use on the synthesis side, but I'm interested to hear other use cases.
Okay. Have you looked into CocoaDB?
I have, but it's discussion about philosophies, but our philosophy has tended not to treat test benches themselves as a test in, but where you have a framework that you add tests to. It's a subtle difference, but it'd be an interesting discussion at some point. But I have looked at it and leveraged some of the work I've done on that. Yeah, for example, we have embedded Python using the VHPI to script components, basically, for test benching. Kind of the opposite of Coco, or maybe the dual of it, so to speak. Rather than have Python control the simulations, this is the simulations are controlled by Python. It's subtle. I mean, I probably need to make a presentation to show you the distinction.
Okay. Are you using VHPI on Windows, or is it more on Linux with the better tool integrations?
Windows. So my understanding so far, the support for tools on the VHPI side has been pretty limited. Model Sim does not, from my understanding from some other conversations I have, never will support the VHPI because they consider the FLI complete and unnecessary to switch. So we use Active HDL currently, but we will probably be migrating away from them soon to Model Sim. And in that case, we probably use the FLI. So that would be something I'd be interested in driving is maybe a different mechanism or something that we could get vendors on board with a common mechanism. So it seems like Aldec's the only company I'm aware of that has support for the VHPI.
Okay. Have you tried GHDL with the VPI interface?
Yes, but it's not VHDL 2008 compliant unless he's changed it. But there's other issues associated with that doesn't fit into our process as well because there's no paid support for G. When we have issues, I know Tristan's pretty responsive, but it'd be helpful, if we could pay somebody to say fix this now or things like that. So.
Okay. I'm a bit involved in the GHDL project. I'm maintaining the compile scripts for Windows. And we did some implementations for VPI on Windows and on Linux to have a better support for CocoaDB. So there was some changes in the last time. And,
okay, so it's more 2008 compliant now?
Most things are implemented. He did a new implementation on generic parameters for packages, nested packages. You can pass in functions into packages. So these features are new, and I think he's now working on unconstrained records. So the gap is filling.
Okay.
And if you have wishes, just write an issue on GitHub, and he's going to implement it sooner or later.
Sure.
Okay, so I think Renee won't show up in the next minutes, so we go on. We already had it in the official working group meeting, the floating point HDL packages from Mr. Bishop. We have moved them to a new repository. So last time they were stored on our organization under VHDL. I have moved them to a new organization group. It's called FPHDL. And there's only one repository for the floating point packages. And we have decided that the bug fixes and updates for the official packages, so these packages which are already included in VHDL 2008, are going to the IEEE. There's a separate repository on GitLab. Then there are packages for capabilities, compatibility for VHDL 93. These packages will stay in this repository, and the third part are packages on top of these presented ones here. Maybe these are going to CoreLib. So that's the current decision how to handle all this stuff. And
yeah, Patrick, I would recommend getting out any new stuff out of there immediately. My big concern is that we don't want any other organizations laying claim to anything that's other than what could be potentially theirs.
Yep.
And that was the whole thought of the isolation. So anything that is a prequel or derivative, it depends on how you look at it. It is definitely a prequel to the IEEE stuff. Should be in that stuff. Anything that's not related to the current IEEE stuff should not be there.
Yep.
Because we want that whole thing pure, so that if anybody decides to lay any claims to it, we want the history of that other stuff gone too. Because if anybody decides to say, hey, you can't release the vendor patches, at least it's not going to hurt anything else.
Yep.
And that they can't, by its presence there, make any legal claims and encumber you from us or David from going forward with it.
Yep. So we have these 3 parts, and I think it's a good isolation.
Yeah.
So what's next on my list? Yeah, I already said it. The packages from David Bishop. Yeah, I'm invited to a simulation Stammtisch at Fraunhofer. It's a local research institute here, and I will give a short presentation on open source projects, and it's a possibility to show what's the open source group about, what other projects are existing, and maybe I can talk to the local guys there. They are doing simulations, digital simulation and analog simulation with VHDL. So maybe we can find other persons interested in participating. Yeah, the third point on my list is I transferred some of the proposals from the working group into the wiki on VHDL.net. Can we mark these proposals on the P1076 list as closed, or how do we cope with these proposals?
How about closed/transferred?
Yeah. So I've copied the TBV proposals. Can show this here. These one are copied.
Okay.
And I think the generic list.
The associative array thing. I was digging through my email the other day. Does anybody have anything on that? Because I found something that Peter had done quite some time ago about a proposal, or was it a proposal or just a white paper on using the generics to do an associative array package.
Okay.
There may have been some discussion on the news group.
No. This was a working group stuff from the Accelera working groups just ages ago. I inadvertently came across it the other day in my email.
Oh, from me? You think?
No, I'm sorry, from Peter Ashton.
Okay, gotcha. Okay. Too many Peters here.
Yeah. So Thorsten Meissner is working on an implementation.
Yeah.
And there's already some code in the repository. And we have the original text here filed under TBV2. It's from 2003. Yeah. So I think these proposals can be marked as closed or transferred on the original list at IEEE. So less work for us on the other side. Yep. Then I think you don't get an email from Fossey. There was an update email on a nice project. I want to mention it here. It's called Discover Fossey, and Fossey stands for Free and Open Source Silicon. And he's grabbing all the repositories on GitHub and searching for tags like VHDL, Verilog, System Verilog, and so on. And his list has 2,900 entries, and you can search here for VHDL projects, or you can say I know OSVVM, and you get some information about license, language, how many forks and stars are put onto the repository, and what's the update state. So yeah, it's a nice list, and I didn't know that there are almost 3,000 repositories on GitHub covering the topic of hardware design or verification. Yeah, it's a nice tool if you want to try it out. And I think we are now going to the big official part, OSVVM. I think most people already know the links. It can be downloaded on GitHub, and yeah, there's a website osvvm.org for further informations. And now I will switch to the screen from Jim, and everybody should see this presentation. So Jim, go on.
Okay. So what's publicly available is OSVVM. What's privately delivered as part of our training classes is the plus part. Long term, the plus part will be part of the official release. Some of it's just stuff that I'm not yet willing to support to the general population, but I am willing to support to our training customers. So, okay. So what is OSVVM? It's a methodology, just like UVM is a methodology. But and just like UVM, it's a open source library and methodology that supports constrained random functional coverage. And then beyond functional coverage and constrained random, we do a randomization methodology that we call intelligent coverage, which is basically use the functional coverage holes to help generate our tests. We'll talk about that in here. We do transcript files, alerts, logs. This is all part of the alert log mechanism, the transcript files, alerts, and logs. We'll talk about that. We have a package for memory modeling, which basically uses sparse arrays to allocate memory. It's one of the classic approaches, but more importantly, what we introduce is a package that allows us to create a memory by using protector type methods. And what's underneath no longer matters because what's underneath can change without impacting, or theoretically anyway, without impacting the user. And then we also have scoreboards. Now, the plus side of things, scoreboards, by the way, is new. It's was intended to be the 07 release. It's going to be part of the 10 release. We're waiting on one more interesting feature coming from a third party before we release the October release. So it's going to be the first step of something exciting. So plus transaction interfaces. So with SynthWorks, we have a methodology for doing transactions, for doing basically what we're trying to do in the VHDL working group is bundles. It's a lot less formal, but it's pretty similar. So it's going to be a nice transition between the two. One of the things that's required to do these transactions is to be able to push things through interfaces. We have to use in out, so we need resolution functions. So we have a package full of resolution functions, and we're working actually on a second generation of that. We have a package full of handshaking primitives, and I'm working on a second generation of that right now too. Okay. Some of those are, the reason I hold some of these things back is some of these things, the resolution functions, support for applying a bit resolution to an array. So applying the resolved function of standard logic to a standard U logic vector is not well supported. Some of it's supported through simulator magic still, and not through an actual support of the feature yet. And handshaking primitives are evolving, and I'm making a consistency sweep through the naming of all of that. Okay, so the first big thing in OSVM is randomization. Now, VHDL does have the uniform function or uniform procedure, and it's kind of hard to use. So we're creating a layer on top of that to help use it. Also, you have to be, whenever you're doing randomization, and this is what was wrong with Verilog, is you need to be very careful about having, for each separate randomization, you need to have a separate set of seeds. Verilog had one shared seed for their randomized function. So that's what went wrong for them. In VHDL, the uniform procedure does not grab anything from a universal place. You have to pass that information with it. Okay, so the first question, the first thing, what do we do with randomization in our testing environment? We're looking to randomize values, modes, operations, and sequences. And it's really ideal when we have a large variety of similar things, okay? So, for example, testing a FIFO. We might look at a directed test, and this diff count thing is actually perhaps mislabeled. It's actually the number of words in the FIFO right now. So this directed test of the FIFO, step one, I filled it up to know how big is the FIFO. So I did it to do two things. One, to size the FIFO, and the other one, to fill it up and then empty it. Separate tests. And then run it for a while. That's the middle part here. And then take it to full and actually try to write one more word, see that things are successfully held off a number of times. Take it to empty and run it empty for a couple times and try to read it to see that mechanism is successfully held off. And certainly if we looked at our test plan, we can check off all the little boxes in our test plan and say, yeah, we tested it. But really the question comes down into is, how comfortable are we with that test, that test actually replicated the real conditions that we operate this FIFO in, and there isn't any weird interactions that'll happen as we're actually running it. Okay, so what constrained random allows us to do is, what we can do then is apply a pattern to filling and to emptying, like, and you see this in the ALDEC, OSVM ALDEC examples. That was actually derived from a SynthWorks example. But basically what we do is we apply a burst of data and an idle time between the bursts. And we'll just randomly do that. Okay, and we'll actually, in one of the tests I do, I set them up exactly the same. Okay, but the randomization takes care of wandering them both in different directions because they both start with different seeds. Okay, But when we do randomization, we have to be watching the functional coverage, and that's what these read empty cov count is. Cov count is the number of times I've seen a unique read empty condition, and then write full cov count is the number of times I've seen a unique write full condition. And again, diff count is the number of words in the FIFO. And all I'm doing with diff count is I'm displaying it as an analog signal so we can get some sort of feel for what is the test actually doing. And you'll see I did the same thing at the beginning of the test, filled the FIFO, emptied it, and then started running it. Okay. And we get some balance of something that we're doing, but certainly you can see that the test wandered quite a bit more than a directed test did. Okay. And you can play with the constraints, with the different constraints that we have on this to get a different pattern in here, let's say. Okay. Benefits. Well, what we're looking to do is get realistic stimulus in a timely fashion. And when we say timely fashion, we mean to write the test bench, because that's where we invest a lot of time. And it's not running the test, because certainly a randomized test is going to take longer than any equivalent directed test. Okay, so the basic rule of thumb then is use randomization, but be aware if it's not faster to write the test, or the test is not more thorough than the previous test, then use another method. Okay, so this directed test, it did take some time to write it and get it right. The randomized tests also take a similar amount of time to write and get it right. Okay, so what do we have as far as randomization? We have a number of library utilities then. We randomize a range, 0 to 15, randomize a range except exclude some values. And picking some particular values, that's not uncommon. Picking the values you randomized previously is also not uncommon. Note this parameter that we're passing to is an integer vector. That's why it takes an aggregate, pass it in. So that's what that thing in yellow there is. It's an aggregate. Randomizing a set, we pass in a set as an integer vector value. And we have sets with excludes. By the way, excludes here with sets really only makes sense when you're excluding previous values, because of course, if you had static values here, you could have simply subtracted those out of that original input array. Okay, we have weighted randomizations in here. A weighted randomization is all do 7 of something, 2 of something else, and 1 of the last one. And basically then, what do you do with these? Well, you sum up all the weights. The weight, and I always make the weights add up to 10 or 100 or 1,000. And then you can basically read these things out as percentages. So these all sum up to 10, so that we generate the first value 70% of the time, the second value 20% of the time, and the third value 10% of the time. And the values you generate by default when you just pass in an aggregate like this will be the indices of that array, which basically start from 0 for the first one, and then 1, and then 2. Okay. And then we also have the ability to specify both a weight. You'll note I use the same weights just so you can see the 7, 2, and 1, and the values 1, 3, and 5. So we pass them in as a pair. Okay. We had to give it a different name here, unfortunately, because VHDL doesn't do any introspection of composites, meaning it can't tell the difference between this composite 7, 2, 1 and this other composite that has the weights and the values in it. Okay, so by itself, this is not constrained random. This is just randomizing values. You actually have to write some code wrapped around it. For example, some code we can wrap around it is we can do a distribution 70, 10, 10, 5, 5, and basically then under the 70%, we'll do normal transfers. So we'll set up a normal transfer. What I'm doing here then, operation data values, is I'm setting up what's happening in my transfer. I'm going to actually do it with the transaction that's shown at the bottom. Parity error, 10% of the time I want a parity error, so I'm going to set up a parity error and set up some particular values of data for parity errors. And then we'll send our transaction. You'll note you also see some other stuff going on here. The scoreboard model is in play. I'll show you the use model for that in a little bit. Okay, so this is constrained random. In VHDL, it's some randomization with some code, with some transaction calls. It's certainly, if we had a solver in play, we could get this more balanced than what we're getting here. But for the applications, for the patterns that we use with constrained random and VHDL, it's good enough. And what I'm going to show you in a minute when we talk about intelligent coverage randomization is that in any form of constrained random test, there's going to be a significant amount of duplications, whether you use a solver or not. Okay. Okay, so the next thing we have to be concerned about is test done. Did I do everything? Okay, so how do I know a test did everything what was intended? And in particular, as complexity grows, are you sure you did it? Okay, because if you flip back far enough, we used to do chips without simulation. We just laid down the gates and reasoned through what the gates were supposed to do, reasoned through the timing, and did it. And you could get away with that because things were small enough. Well, what I'm saying here then is, as complexity increases, does that directed test really test everything you thought it did, or is there something interfering with that? And you're not really getting the test case you thought you did, and although the test case passes, it's not testing everything you thought it did. Okay, so just like we used to assume our design worked by inspection, when we're doing directed testing, we're doing coverage by assumption. Okay, so we have a couple metrics for coverage. One is code coverage, the other one is functional coverage. Okay, code coverage is cool because the simulator automatically does all this stuff for you. But the problem is that while code coverage clearly identifies what has not been run, it is a little bit overly optimistic. In particular, if you look at this sensitivity list of this process, if you have any combinational logic in your code, this process runs on every delta cycle in which one of these signals changes. And therefore, you're going to be collecting coverage on every delta cycle when really you should only be collecting coverage at the last delta cycle before the clock edge that's going to sample this. Okay. So again, my opinion is over optimistic. There's other issues with code coverage also. It just doesn't do everything functional coverage can do. I think we'll address that here. Okay, so what's functional coverage? Functional coverage is basically code. So you gotta do some work to do this. But it's code that observes execution of test plans. You identify things that are important in your test plan, requirements, features, boundary conditions, and then you strategize, how am I going to observe this happening? Okay. And if we classify functional coverage, looking at it the way the other languages do, the standard E calls this item coverage, System Verilog calls it point coverage. I went with item coverage because there's point coverage and there's coverage points, and they're totally different things, and it's confusing to use that word in different sequences to mean different things. Okay. Okay, so item coverage basically tracks relationships within a single object. So let's say you're doing some sort of transfers, maybe a DMA transfer. And what we're worried about with DMA transfers is big and little transfers. So little transfers might be 1, 2, and size 1, 2, and 3. Big transfers, let's say this controller only does up to 255 transfers, 253, 254, and 255. Okay. And then the median range is, we want to see a certain number of done, but we're really not as concerned about them. So we'll just bin them together somehow. Okay, this is an example of something that we can do with item coverage. I think we'll take a look at this here. We may or may not. Okay, cross coverage. Cross coverage allows us to track relationships between separate objects. Okay, so for example, you're making an ALU. It has 2 separate inputs to it. Each input can pull from a certain number of registers. And what we might want to ask is, has every pair of those registers on input 1 been used with every pair on input 2? Okay, that's cross coverage. We're correlating between 2 different inputs. Okay, so the benefit, well, we're actually looking at, we're tracking what's observed in a test. And in my mind, we're done when we get 100% functional coverage and 100% code coverage. We want that code coverage metric because if we forget something in our functional coverage, the code coverage provides a fail-safe for us. Okay, so what we have then is we have coverage package. Certainly, you can write functional coverage without coverage package. It's just a heck of a lot easier. Coverage package is supposed to make it easy. Okay, so it simplifies the definition, collection, and reporting of coverage. Internally, there's a protected type that we have a shared variable with, and we build a data structure behind the scenes. Okay. It also, by having a shared variable, by having a protected type, we can have internal variables to this protected type and have configuration settings within the model itself so that we can make different things happen with different models. Okay, so in this presentation, to keep it short, we're only going to look at the cross-coverage example. You can certainly, there's other recordings of this. Aldeck has some on their website. So you can see the other example there if you want. Okay, so the ALU, it looks something like this. It has an 8-input mux, 2 8-input muxes selecting into an adder. We have our general purpose registers feeding these. Okay, so generally they're going to match the size. The number of muxes here are going to match the number of addressable registers or general purpose registers internal to the device it has. Okay. And what we're looking to see is that we've covered everything in this matrix. That's cross coverage. Okay. Okay, so with OSVVM, it's pretty straightforward. Step one, we create a coverage object. Shared variable, it's declarative. But that's all we do in the declarations. We create the object itself, the container, the whole, the data structure. And then we call the method of the protected type. Now, note, this is pretty similar to what we do with regular procedures and such, except now we're calling it in a funny way. We're basically passing a reference to the object acov by the call. It's acov.addCross. Okay, the way we would have done that conventionally is add cross, and perhaps the first parameter would be acov. So shared variables and protected types add a new twist. I think that twist was a reflection of class-based stuff, okay, done by other languages. And then we call it with 2 parameters, genbin 0 to 7, genbin 0 to 7. Genbin is basically a helper function that helps structure things for these add cross, to make add cross calls a little bit simpler. And it's also, I looked a lot at the system Verilog syntax. So system Verilog had something like that designated that this is a item bin, for example. So genbin in some ways reflects a single item bin. And it says, then genbin basically says, take this range 0 to 7 and break it down somehow. And there can be a third parameter that tells you how many bins to break it down into. But if you don't supply that third parameter, it breaks each one of these down into an individual bin. So this is going to create, each call to genbin 0 to 7 is going to create 8 bins. And they're going to have the ranges 0 to 0, 1 to 1, 2 to 2, and so on. And then it's going to do a Cartesian cross of that. We'll show you a little bit more of that on the next slide. We're going to go in and query the model. Are we done? While not is covered loop. Call our uniform randomization. So we're going to just randomly pick source 1 and source 2. This is exactly what constrained random would do when these 2 objects are independent like they are here. Okay. We're going to do an operation based on these values. We're also going to collect the coverage. Now, you could argue maybe this is the wrong place to be collecting coverage. So, and the reason why you might say it's wrong is because you're collecting coverage at the same place you're applying the stimulus at. So in order to be able to collect the coverage here, there is one precondition, and that is you absolutely must validate that the only thing do ALU op will do when you call it is apply these values as you told it to. And if you can assert that, then it's sufficient to collect the coverage here. Otherwise, you'll be collecting the coverage in a model that's observing the interfaces. And that's okay too. You can do it in either place. It's equally correct. I just wanted to keep a nice, small, compact example here. So put it all in one. Okay. The one thing to observe here is if you looked at a system Verilog implementation of this or an E implementation of this, of a simple Cartesian cross like this, really, as far as complexity, as far as verbosity, OSVVM is every bit as concise as they are, every bit as easy as they are. And that's one interesting thing, because OSVVM is a library versus their language syntax. Okay. So the method add cross basically takes up to 20 parameters. So you can do up to 20 parameters. Warning, doing 20 parameters is if you have even just 2 choices on each one, you're going to have a million different, a data structure that has a million objects in it. So beware of that. You don't really want to be doing something that large unless you're really, really careful or know the size of what you're doing. Okay. And then basically what happens behind the scenes is we build a data structure. Okay, so the first call to add cross, there can be multiple calls to add cross, sizes the data structure. So this one sizes as a cross of 2 objects. Okay, and now the object is required. Every other call to add cross must be the same size. And there's checking in the background that makes sure that that happens. And it will fatal error on you if you make a mistake. Okay. And then basically what it's doing then is this gen bin is creating some descriptors for these item bins, and we're just doing a cross of it. So it just becomes, we're taking that table, that matrix, and we're linearizing it into a table here. So we have 0 with 0, 0 with 1, and so on. Okay, until we get 7 with 7, or 7 with 6, and 7 with 7. Okay, and in here, this is the big deal about coverage, is it keeps track of the count. Okay, so how many of them did I see? Action says it's a normal count bin. At least value, I named it after System Verilog and E because they both consistently call it at least. But really, this is your coverage goal. Okay, and we do, in OSVVM, we can do a bin by bin coverage goal. So this says every item in this bin must have 1 item in it. Okay. Now, here's what's cool about OSVVM. Well, other languages, when you're doing cross coverage, really focus on doing Cartesian crosses because they're declarative, okay? And they don't have a strong language to already support them. Whereas OSVVM, we're actually writing the add cross, constructing the data structure in sequential code, and that's a huge advantage because we can do anything we need to do, and we can use the existing language to adjust things. Okay, so here, this 2 parameter here and 4 parameter here is actually setting a coverage goal for each of those bins. So it's actually setting the coverage goal to 4 for the diagonals. Let me flip back a little bit more than this one, one more. Oops. 10. Go. So what you see we're doing here, and is we're putting 4. Where'd my pen go? There he is. Oh, the color's white. How exciting. I was all excited. I thought I was going to get to use that really cool feature of PowerPoint. Arrow options screen. Well, anyway, sorry. I'm not smart enough on PowerPoint yet. Let's one more try. Pointer options.
Ink color.
Yay. Let's do red because everything else is. So it's putting a 4 in here and in here, and it's putting 2s in all the other positions. So it's basically this diagonal here has 4 on it. Everything else has 2. That's where we're going with that. Okay, now. So let's get out of this silly mode. Let's go to 14. Let's just see if it'll click. Yay! Oops, 13. Okay, so that's what's happening here. So we can basically, again, do anything we need to do. We can use ordinary VHDL code. The if statements can be based on generics, so we can be doing things conditionally based on a generic, but also the whole coverage model can be set up via constants, and those constants can be passed via generics, and hence the whole coverage model can be passed into a design as a generic. Not only can, it's been done, and it's been done, actually was explored by parties other than me. So I thought that was pretty cool. Okay. Okay, now here's the big deal. Constrained random tests, whether you're doing it OSVVM style or system Verilog style, underneath the hood, there's uniform randomization. And basically, what happens with uniform distributions or uniform randomization is they repeat, and they repeat a heck of a lot. Okay, and in verification, basically our goal is to get n test cases. Okay, 1 of everything or 2 of everything. Okay, the problem is randomization theory tells us that it takes an order of n times the natural log of n randomizations to do this. So the natural log n, that multiplying factor there, is your repetitions. Okay, so let's take a look. Basically what happened in this example then, the one we ran on the previous slide, is with a given seed, because it will vary drastically with seeds, but I did this before I picked this seed to show good things about constrained random and not show bad things. So this test took 315 iterations. 315 iterations is just slightly less than 5x. Too many iterations, 5x more than what you needed, the 64 ideal. So the conclusion is that the log n factor can be huge. Okay, and basically what this diagram shows down here then is that to get a 1 in some of the other bins, oh, there's my pen right here, 9, you see a bunch of them, 10 and 9. This is not an abnormality in our test case, because you saw our test case was very simple randomization. This is not something wrong with uniform. This is just properties of uniform randomization. And in fact, other studies done by vendors doing intelligent test bench tools showed that constrained random can be 10x to 100x in this repetition factor. Okay, so what do? Well, OSVVM has this really cool capability where we can randomize across the coverage model. So we're creating a coverage model, right? And ideally what we want is 1 in each one of these bins. And basically OSVVM has this capability to do a random walk across the coverage holes. Basically all it's doing is you tell it to randomize and it selects a hole, a thing it hasn't fully covered yet. Okay. Note, there are intelligent test bench tools out there. Unlike OSVVM, they're not free. They're a significant add-on expense to your current simulation methodology. And they're not currently portable, although they are. Accelera is working towards that, but I haven't really heard too much out of them, and they've been working on it for a couple of years now. Okay, and it looks like it's going to be graph-based, which means then that you're back to being captive in some ways to a tool vendor. All right, so what do we need to do intelligent coverage randomization? Well, it's very simple. We throw out those 2 calls to uniform, and instead we call a method called ranCovPoint. So this is not saying get a point coverage item, it's saying get a coverage point out of the bin. Okay, so we have a bin. Potentially that bin can be a range. We're getting an item that's inside of that range of that bin. Okay, so there's 2 randomizations going on here. One to find the bin that you're in, and another one, if the bin has a range, if it's 1 to 5, say, to pick a value between 1 and 5. Okay, and that's the only change we have going on here. So our methodology is very simple. Forget about randomizing. Okay, forget about creating a randomization object. Forget about randomization constraints. Write your functional coverage first. Then anything that you can randomize using the functional coverage model, do it. And then refine to get the rest. Okay, not going to say this does everything. Okay, we're not. But it is a very cost-effective solution. And in this case, it runs this example in exactly 64 iterations. Okay. The other thing I wanted to point out that we can do is we can set weighting. You already saw this on the cross coverage example. There's my cursor. It's tiny. Here I'm setting my coverage weights or my coverage goals for each bin separately. And this normal over here is a constant. Oops, is a constant. Okay, parity is a constant. It's of the appropriate type for a item coverage thing. Okay. And it's created by GenBin. And then we loop until we're covered. We're randomizing a point for our operation. We're using the case statement just like we were before with constrained random. We're using the case statement now to parse out, to select out which bin here was selected. Okay. And then we find out which bin was selected. We set up that operation, and then we do that operation. The difference between this one and the previous one is it does exactly the pattern specified, the pattern being the distribution in here. I'll note for some things, doing those exact weights is not that important, other than you want to make sure you do at least one of everything. So for example, this is setting up a UART test. We at least want to do one break conditions, but we don't want to do 1,000 of them, right? So this then, by specifying a small, relatively small break condition, you're going to get it. Whereas in the constrained random, you do 100 iterations, you're not necessarily going to get it. You might have to run 1,000 iterations to get them all. Okay. Okay, so basically then, that's our randomization capability. Okay. There's actually, I shouldn't say that. There's actually quite a bit more features behind the scenes. And with the randomization, one of the things I'll note is how does it converge? So you saw without intelligent coverage, how that model converged. It did one of some things and did 10 of others. With intelligent coverage, when we have coverage goals that are higher than 1, that are higher than 5 or 10, we start getting interested in how are they distributed, and we have things to control within the OSVVM model, within the coverage model, how to control those. We have things beyond intelligent coverage is basically what I'm saying. Okay, the next capability we have is simplification of printing. Because test benches, we do a lot of printing. We want control of things. So we introduce the concept of transcript files. Transcript files give you the ability to write everything from a test to a file that you designate in your VHDL code. Basically, do transcript open, it opens the file. Okay. And there's not a lot of magic behind the scenes. The only magic behind the scenes really here is that package has the file handle in it, has the file identifier defined in it. Okay, we have a print. Okay, so we print to that file. Now, if you haven't done a transcript open and you use print, it's simply going to print output. And we also have write line. So if you like the text IO methodology of building things up, you can use write line and it'll print to the transcript file. No, we're not specifying the file name here. This is more like print as opposed to printf. Okay. So all printing, this is the cool thing, all printing in OSVVM uses this transcript file or uses output, or we can also set a mode called mirror mode. You can read more about that in the documentation to allow you to print to both the transcript file and output. And I like using that one when I'm doing the initial debug test. The next thing we add on top of that is logs. Logs are all about conditional printing and can be enabled or disabled. In my mind, logs are optional conditional printing and hence typically are disabled. There's one special one, log always, it's the default, it always prints. Beyond what we print with print up here, logs are also formatted. So they print out some pre-specifications. Generally, the %% indicates it's something coming from OSVVM. Log says it's a log. Always says it's the flag that was used here. And of course, there are controls to turn this stuff on and off. And the other thing it prints is it prints this at time. This is the other thing it prints beyond that. Oh yeah, it's also printing, if you've set up hierarchical modeling, it also tells you what model it came from. Okay, so these are all, and I should point out, back on this slide, I set this name here up to match the instance label of my design. And I set up my instance labels typically so they're the component name _1, _2, _3, and so on, so that by knowing this instance label, I know exactly which file it's associated with. I know exactly which instance of which design it's associated with. The next thing we have is alerts. Alerts are for reporting errors, are reporting things that are invariants that should never happen. The first alert is like a report statement. It just prints, okay? The second alert, alert if, is conditional. It's the exact opposite of assert as far as the condition go. Alert, assert is alert if not, basically. Okay, so we have affirm if, and then we have, or alert if, and then we have alert if diff. Diff is for file comparison. Okay, and by default, they're error level severity. Okay, and severity, I really shouldn't have used that word. It's an error level enumeration. Okay, so it's not quite the same as severity, because severity has note, warning, error, failure. This leaves off note because technically speaking, report note is really a log. All right. The other thing we have is affirmations. Okay, affirmations are for self-checking. They contain both an alert and a log. Remember, logs are disabled by default, so the log isn't going to print unless you enable it. But then we set up a comparison of something of this sort. I say affirm if, and then here I'm doing ID based. Okay, and I'm doing what we're comparing, and I'm formatting up my message. And I format up my message so that it's correct, whether it's an error or not. So it's going to say error if it fails, and it's going to say data is 5. I expected them to be equal and expected a 6. Okay. And then I log. If it passed, I also have the ability to print it out that it passed. Generally, this is off. Let's see if it tells you this. No, it doesn't. Okay, so generally this is off. You have to enable it. Okay, and I don't think I show you the enables here, so you'll have to explore the user guide. It's pretty straightforward, though. Okay, now the big thing is this. When you get done with a test, you call report alerts. And behind the scenes, every alert or affirmation is accumulating the number of errors that happen. Okay, so if it passed, it'll just say %% done, passed, and then the test name. There's actually 2 ways to set the test name. One is to pass it into report alerts. That's fine as long as you don't have any other failure sort of tests in your design. If you have failure sort of tests, you want to be setting your name before this. Okay, and there is a set alert log name function also. Okay, now the failed message depends on what mode you're in. If you're just using simple mode, which I also call global count mode, okay, you just get a count of the errors. Okay, and you get a count of the total errors, you get a count of what were they? Were they failures, errors, or warning? Generally, I keep failures to mean something that says stop immediately. For example, I write a CPU model and I'm addressing one of my slaves. My slave doesn't respond and I time out. A timeout is a failure. Okay, because I really can't continue to try to talk to that device. There's no point in it. Okay. But I can also use what I call hierarchy mode. In hierarchy mode, for every separate model, we go out and get an ID for it. And when we get an ID for it, we give it a name. And then that name actually becomes a name within the data structure. And again, I usually set this based on the instance name. And when we do the report alerts, it will print out the errors from that particular design. Okay, and that can be important. You're running a test. You were supposed to turn off one of the models. You forgot to do it. The design fails because this model's doing checking on nonsense. Well, the report alerts is going to immediately tell you that. You're getting 5 errors from the CPU model it wasn't supposed to be on. Oh, okay. Turn it off, rerun the test, life is good. Or, oh yeah, we need to go start debugging there. All right, and this hierarchical report is one of the things that's different in OSVVM from the other methodologies. Okay, that we can print out the errors from each separate thing in a summary at the end. Okay, that's a quick synopsis of our alert log capability. Again, there is quite a bit more stuff. There's enables for alerts. There's enables for logs. It's all set, log enable, set, alert enable. Tried to make it readable, at least in English, and intuitive so that things are similar between different things. Okay, so the next thing we have is memory modeling. All right, creating a memory model in this method is horrifically expensive if the model's of any size. So creating something that's an array of standard logic vector that is a signal creates a lot of storage. Now, something small like this, you can probably get away with it. Okay, something large, you want to start thinking about, okay, how am I going to make it more efficient? Okay, and one way to make it more efficient is by using what we call a sparse data structure. And a sparse data structure basically has an array of pointers, and they point to some number of storage elements, typically a block. So you want this to be like 1024 values or 4K values or something of that sort. And you want it to be a type that's readily storable. So you don't want standard logic vector, you want something like integer. Because with integer, for 32 bits, we're taking up one storage location, whereas standard logic vector, each of those bits there has 9 values. Okay, so each bit takes at least a nibble to store. Most memory models, we don't need that. Okay, most memory models, 0 and 1 is sufficient. We may also want to store some sort of sense of X. Okay. Memory package right now, if a bit has an X, it makes the whole word be an X. There's an expense to that. And the expense is you don't get the full 32 bits, you only get 31 bits. Okay. So we make the word negative, basically. That is going to become a policy that you can map via generics to the memory model over long term. We will have other policies. One that says ignore X's, make them 0s or 1s. The other one that says for every 32 bits, keep 64 bits. And one of those sets of bits indicates which bit is an X or not an X. Okay, so it's a protected type again. The basic things are write and read. We have read as a procedure. We have read as a function. I wanted read to be a procedure just like write. It's not always convenient because this out here defaults to a variable. Sometimes we want to assign it directly to a signal, which makes the function much more convenient. We also have an init. Basically, when I was designing the package, simulators, in fact, this package was defined long before generics were even part of the languages, before 2008. I think I did this around 2006. So basically, meminit sizes the data structure. So it's all sized dynamically. It's interesting in that way. We have an erase We have reading, hex, binary, hex, writing, hex, binary. By the way, these are all done in a format that's compatible with Verilog, that's compatible with the same format that Rick Munden's and I think Ray Steele's project used. Free Model Foundry. There we go. That's what it is. Also, internally, we have alert log IDs because these will all can report against those alert log IDs. We have a couple different ways to set them. One is getting them and passing in a name. Another one is just passing in an alert log ID type that already exists. Okay. So how do we work with this thing? Well, step one is always creating a shared variable to hold the object. Step two is initializing it. Concurrently, you can call this meminit concurrently as I show it here. Historically, it did have to be in a process. So if you run into some problems with some tools, there are some older tool issues that require meminit to be called in a process. Then it's just a process with a wait at the end. That's all it is. Okay, so it's not any more complexity than this. Call write just with address and data. You call read with just address if you're using it as a function, it returns a data value. It's really that simple. My goal was to make it as simple as a memory model constructed using the array of array methodology, and it came out to be actually a little bit easier because with the array of the array methodology, when you're indexing the array with a standard logic vector, you have to convert that standard logic vector to an integer. Here, you don't have to do that. Okay, so that's memory modeling in a nutshell. This has been part of OSVVM, I think, for over a year now. A year ago, June, I think I dropped it in. It also has a complete user guide and such. And all of the OSVVM packages have a complete user guide to them. And it's a PDF file in the docs directory. Make sure you look in the OSVVM release docs directory. Okay. And as opposed to the examples files with its separate docs. Okay. Scoreboards. It was intended to be out with the 2016-07 release. The 2016-07 release got delayed till October. It's coming out hopefully by the end of the month. Again, we're waiting on one thing from a third party. Okay. And yeah, okay. It's going to be one of the vendors. Actually, I will spill a little bit of it. It's going to be one of the vendors is create an API to start collecting, to start copying OSVVM coverage into their internal data structures so that they can do some further handling with it. Okay. Self-checking and scoreboard. So a scoreboard is basically a data structure to help you out with self-checking. They work very well when the data flowing through the system is easy to predict exactly what it's going to be. For example, when I'm sending UART data, for example, I'm expecting the same stuff to arrive on the other side, maybe transformed a little bit. Okay. But when I start to look at things transaction-wise, I'm sending 4A, I expect to get 4A. Or I'm sending 4A, but I'm also injecting a parity error, I expect to get 4A with a parity error. Okay. Sometimes there may be a need to make small transformations, and to handle that, OSVVM has a check function that we actually pass in to the scoreboard as a generic function. Okay, so this is the first OSVVM package to introduce generics. It does have a compatibility mode, so you don't have to use generics if your tools don't quite support it yet. But what I support is the one that does generics. Okay. So scoreboards may handle small data transformations, may handle out-of-order execution via tags, and may handle also dropped values. Okay. So to handle drop values, we need to have an indication from somewhere that indicates the designer test dropped something. so that we know instead of just to do a check, that we actually go out and do a search for the new value in the scoreboard and drop everything in between. Okay. So again, this scoreboard is a generic package. We actually pass in the type of the expected value, the type of the actual value, the value that's received. These can be different types. They can be the same type. A match function, excuse me, it's okay. It's not called, well, the function we pass in is not called check. It's called match. Okay. And an expected two-string value and actual two-string value. Okay. And then internally to the scoreboard model, we have push, we have check, we have pop. Of course, we have set alert log ID to give a scoreboard its own alert log ID if we need to, or to allow it to share the one of, let's say it's in the CPU model, the share the one of the CPU model. We can set it up so it does that. The basic use model of the scoreboard is this. We set up a shared variable. It's of scoreboard P type. And then we set the alert log ID. Okay, so this is the, okay. So we just set the alert log ID. I was going somewhere else with that where this was not going. And then we'll push something into the scoreboard, followed by doing a transaction. You'll see the UART send there. And then on the other side, separate process, we'll do a get to receive the value, something from the UART, and then we'll do a check. Okay. And then at the end, we'll do report alerts to collect our errors. Okay, and inside the scoreboard, we'll actually be logging the alerts there. Okay, actually it'll be logging affirmations inside the scoreboard because the scoreboard's doing self-checking. One of the interesting things about affirmations that I didn't mention is when you do the report alerts, it will tell how many affirmations it checked. Again, the affirmations are indicating how much self-checking you've done. That's an important thing to track because the self-checking is an indication of how much self-checking somebody add to the test bench. If they didn't add any, if they just used alerts to check data parameters, there's a lot of alerts used in the OSVVM library. It's not a very interesting count. So we want to check the quality. It basically gives you a quality metric of the test bench itself. Okay. So the scoreboard is a generic package. You do have to map it. Basically, we will reference a package before the instance that defines the types, that defines the functions that we need. Okay. And we have here the UART stim type, the type we're sending in, the UART receive type, the design inter task, UUT receive type, the match function that needs to get passed in, the two-string functions. They can be called two-string. They do not need to match these names. I created these names different because I was worried about what happens when these two names are the same. Do I have ambiguity problems then? I would say I got lucky that I made these two names different because it turns out one of the oversights in VHDL 2008 is you cannot do named association if the two parameters have the same name. And certainly when there's subprograms like that, they could have the same name. So you do want to make sure you keep these things unique when you're writing your own stuff. Okay, so what does the match do? In this case, this shows you an example of the match for a UART, which is kind of cool. What this is basically saying is if the expected value is a break condition, the only thing I'm going to check in the actual is, did you get a break condition? I no longer care what data did you say you got. Okay. Otherwise, I expect everything to match. So I expect the break, the parity, the stop error, the data value to match between the two. Okay, so this is an example of how the match function corrects for small differences between things. Okay. All right, so that's scoreboards. So that's everything up to this point has been OSVVM or OSVVM soon. I think I actually pushed the scoreboard model in my most current release on GitHub. So that's not an official October release yet, but if you want the pre-release stuff, I think it is out there. Well, the next big thing we have to get going in VHDL is a transaction level modeling. And how do we abstract an interface? That's one of the problems. And there are at least 3 unique ways to do this right now out there that are being popularized. There's the OSVVM methodology, or there's the SynthWorks methodology, I should say, which is OSVVM plus, which I do expect to be out soon. Then there's the probably soon, meaning probably early Q1 of 2017. Okay. Then there's the VUnit methodology, and then there's the UVVM methodology. Okay, so this is where we all differ. Okay, and we also somewhat differ on how we view the world, so that's kind of interesting too. But even though we view the world differently, I think we all use the same block diagrams, which is also interesting. Most TLM test benches, whether it be VHDL or System Verilog, are drawn with the same picture, which is rather curious. So in this approach, then, basically we have models surrounding the design or test. Generally, in my world, when I say model, I mean entity architecture, but be aware out there in industry, many people, when they say model, they could also mean procedure. Okay, in System Verilog, a model is a class, which is a lot like a procedure, or in many ways like a procedure. It has more similarities to procedure than it does a entity there. I think we can agree on that. Okay. And then I use a central model to sequence and or synchronize all the models. Okay. So this could be the stimulus source, but for things that require a huge volume of stimulus, it could simply be directing that model to go out and get the stimulus from another place. For example, if you're doing something that's handling video images, it'd just be saying, hey, go get the next video image from this file or from the current file you're reading. Okay, and then each test really becomes a separate architecture of test control. Okay. Within test control, we create all the transactions. We have separate processes. My rule of thumb is very simple: 1 process per independent interface. And when you think about a UART, the UART transmitter and receiver are totally independent from each other. So you'll have in my world, again, we'll have separate processes for each of these. Okay, so that means then we have our separate processes. We generate our interface stimulus with procedure calls. The procedure calls, so this is one of the differences in other approaches. The procedure calls in this case are blocking, meaning they don't return until that operation is completed on that interface. Okay. Each test becomes a separate architecture of test control. And what's interesting about this is you can have 2 levels of people writing tests then. You can have the person writing the test bench who has to be all knowledgeable about everything in the test bench. But then you can have people writing tests who only have to understand a significantly less portion of VHDL, but they also have to understand the utilities that the rest of the test bench team has put in place. The other part of the intent here is that the entire test is in this file, or nominally can be in this file, and you can review it. And people can look at exactly what's happening within the sequencing. Okay. So transactions then. We're going to have, in any approach, typically we're initiating transactions by procedure calls. That's exactly what we saw over here. We're calling procedures to make something happen in a transaction. Okay. In a procedural approach, we'll also implement all the signal wiggling in a transaction. In an entity-based approach, we will pass all of that modeling information, all of the transaction information over to a model. and then the model will do the wiggling on the DUT interface. Okay. And there'll obviously need to be some handshaking here. The CPU rec is a record, okay? It's a record because it allows us to update, add elements to it. Right now, all the elements of the record are resolved, and we make sure that they're driven to appropriate values. Okay, so what I like about this approach is the model's concurrent. I can have many processes in here. Okay, and that allows me to write my test model in the same fashion as I write RTL models if I want, or I can take shortcuts if I want. Okay, and this is particularly beneficial for when we're doing things like state machines. Okay, you can bundle all of the functionality, the checkers, the result loggers into that one model if you want. You don't have to. You can put them in separate models. This also explains why some languages like System Verilog, since they're doing something that has more in common with a procedural approach, why they put those separate things in separate blocks, because that's the only option they have. Okay, they can't bundle everything. It's not effectively running in a process inside of something. Okay. Again, the code, the big advantage here is the code can be written either behavioral or even in a pure RTL fashion if you want. Okay. The records abstract a connection between test control and model. Okay, we have one record type per independent interface at this point. And we have resolution functions. So we're using unsigned, we're using standard logic. We simply initialize those to Z. I've created resolution functions for integer, time, real, string, although string's cumbersome to use because it has the issues with arrays right now. Okay. We initialize the record on the interface. Don't like having to do this, okay? But right now, we initialize everything to non-driving. And non-driving right now for integers, time, and real is putting a 0 on it, okay? For the resolve functions, in the future, I'm going to a resolved _ max function, and the non-driving value will be the tick left value of the types. Okay. And then one of these procedures that we call in test control is simply doing nothing more than pasting things into the record. So it pastes everything into the record. Let's see, do we have any animations here? We do. Paste everything into the record. And then it calls this procedure request transaction. So this is part of our TButil package. Request transaction basically says, dear model, please take everything I just dropped into the record and use that to go out and do something on the interface, whatever it is you do on that interface, okay? Wiggle the signals appropriately for that. So it's really a high-level thought here of what we're doing. And then when request transaction returns, the model is finished doing that. So on a write, there's nothing for it to return. On a read, we'll be grabbing the data value and passing it back. Okay. And I think at the current time, there was no Boolean to be pushed through to the model. When I have the final release, there will be a Boolean, also a resolved Boolean type. So that will be able to pass. On the model side, to make all this handshaking work then, is the model initially starts out blocking. It has this corresponding wait for transaction call, okay? And the wait for transaction basically gets the indication from the model, hey, I've got stuff for you ready in the record. Now go decode that record, parse that record, and do an appropriate action on the interface, a CPU write, a CPU read, a directive transaction. Signal errors is a directive transaction, meaning it's not something that happens on the interface. It means collect all your internal errors that the model's seen and pass it back to via test control somehow. let's see. Yeah, I left. I left all of this. The rest of the modeling is just normal modeling, so I left it out here. And then synchronization primitives. You saw one set of them here. The request transaction and the wait for transaction. Beyond that, there's waypoint block, and in the final package, that's not going to be its name. That name is going to be maintained, so it will still be there, but it's going to be called barrier synchronization because waypoint block is a barrier synchronization. Basically, what a barrier synchronization is you have two separate processes. When both of them call waypoint block with the same signal name, they will block until they've both arrived there, and when they both arrive, they'll both continue. Okay, so that's what waypoint block is. And I changed it to barrier sync, or I'm in the process of changing it to barrier sync, because that's what the software world calls this sort of thing. Now, since I changed this one to barrier sync, I also changed this one to a similar naming style to be clock sync. Okay, and this is pretty much everybody has some sort of this clock and some delay value. So the delay value is in time. So we'll do internally to this, we'll do a wait for followed by a clock. Typically the delay time will be n clock period. So you'll say 10, you'll call clock sync, clock value, and then 10 times t period clock of something of that nature. And that'll be set up to wait for 10 clocks. And that one is one way to do it. There will be, in the final release version, there'll be other clock syncs that if you prefer to wait for n clocks, you can wait for n clocks also. But that's n clocks is expensive, right? Because you're looping on clock. Whereas when you do 10 times t period clock or 1,000 times t period clock, that's where it gets interesting, right? It's only 2 steps still. Wait for followed by wait until clock equals 1, or wait until rising edge clock. For clocks, I treat wait until clock equals 1 and wait until rising edge clock identically. It's not quite identical, but I really don't think you need the overhead of the rising edge clock in that case, because clock better not be an X. Clock is one of those sacred signals that if it's an X, life is really bad. Toggle and wait for toggle is another handshaking method. One process calls toggle, and it's assumed that that the other process has hit wait for toggle first. So this is for synchronization where we know the arrival order. Barrier synchronization is for when we don't. And it's likely that barrier synchronization will likely be able to replace all uses of toggle. Okay. So that gives you some insight into what's going on in OSVVM and what's coming up in OSVVM. Some of the new stuff that's coming up in OSVVM. And actually, one of those TBVs that asked for synchronization primitives was really asking, oh, I got my mouse back. That's interesting. Pen. Okay. Was asking for this. That's what it was asking for. Request transaction, wait for transaction. I think it had different terminology at the time. But I would also consider barrier synchronization and clocks. Everybody has a clock synchronization of some sort in their test benches. So these are handy things to have.
Okay. So you are talking about TBV7 sync and handshaking?
Yes.
I have it on the other screen.
Okay, let me pop out of my mode here so I can see what you've got up.
This one here.
Yep, looks like it.
Yeah, I think the implementation from Lars is more advanced. Is it here? He had posted it into GitHub. No.
Yeah, we need somebody sitting next to Lars doing documentation.
So yeah, he has a repository under his user account called
Yeah.
synchronization. It was a test, and I think the other one is
Well, you
was
show me some
directly.
code. Don't hop around. Show me some code. I want to know what his interface is because he's not telling me that. I have to go look at his code. I don't like that. But
So source synchronization.
yeah, this is a different set of stuff.
Resolve event is triggered. Trigger wait on. Yeah.
Yeah. Yep.
But I think the internal stuff from vUnit is more advanced than this implementation here.
Okay. Now,
It's
eventually,
just a
OSVVM is
subset.
going to have something released here too. So, or we're going to release. So I'm going to be releasing what is part of OSVVM or part of SynthWorks plus stuff to OSVVM.
Yep.
And then we can try to come up with how we can merge things together.
Yep. Of course. You were talking about directed testing and your cross coverage model.
And coverage modeling.
Yeah, and coverage modeling. Do you always need a direct function? I think it's a correct term here for an input to an output, so you can reference back from the bins to what you have to generate on the input. I think it's easy for multiplication and for an adder or subtractor, but what do you do when the unit under test is more complex? How can you use your coverage holes to direct the uniform data or the random data?
Well, yeah. So can you put my screen back up?
Yep. 1 second. Yeah, it's back.
So basically what you've got to do then is it would be a pattern similar to this one. You'd have, first off, I've got to go into screen mode to get all the things. Come on. Pen. Okay, so first, step one would be you define, gosh, oh, it's white again. I'd like to know who the rocket scientist is there. So at step one, define your coverage model, whatever it happens to be. Okay. Step two, do your randomization. So here, so if your observed coverage was trying to drive things that were different, now at least what you've been able to do with your bins is you've been able to classify what is it that I need to see, right?
Okay.
And then over here, what you're going to be quantifying is what are the steps that I need to make that happen? Okay. And in this case, there were very simple steps. Randomized data, maybe. Yeah, we're still randomizing the data. We're copying the operation out of here and maybe randomizing some other stuff. But you're writing code, right? So what we've done with the coverage models, we've classified the different sorts of things we need to do. In each one of those, we don't have to be putting the transaction down here. The transaction or transactions can go up here.
Okay.
And given, mapping outputs to inputs can't be impossible, or we would never be able to do directed testing. Okay, some of it might look a little bit like directed testing, and that's unfortunate, but it's the only way it's going to be. Some of it you might be able to algorithmically handle. So what you're going to have is a mix of code in here of stuff you can randomize and stuff you can't.
Okay. Yep. Makes sense.
And you know, I would have to see the problem, and we'd have to take it on a problem by problem basis. So I do offer all my students and basically anybody else out there, if they have a problem that can't be handled right now, I want to know about it so that we can start working on what is the solution. So if you have a use model out there that's not working, give me a shout.
Not yet. I was just figuring out how to load OSVVM into our POC infrastructure. So
Cool.
we have a pre-compilation step. It's already included, and I tried it on our sorting networks. So we're generating random data for the sorting network, and there's a simple test currently at the end. It's just checking if one output is greater than another one.
Mm-hmm.
So we have a sorted order. And I was going to add the scoreboard. So I know the input data of every step. I can pass it into the scoreboard. And then we can check if also each input has arrived at the output. Because testing for ordered data is not enough. You have to test if the input was not destroyed or changed.
Or not, not dropped.
Yep.
That's interesting.
So
yeah, that could almost be covered. Wow, that's an application I hadn't really thought of, but that could almost be handled also by a dynamic coverage model. Meaning you're adding bins to the coverage model as you run.
Okay.
And every time, wow. That would require some new stuff though.
So what we are doing is
merging on.
we have
really like doing.
We have an implementation. Oh, maybe I switch back to my screen. We have an implementation of this Bitonic sorter. So we have this sorting network, and you can push in values in every cycle, and you get results. I think after 5 cycles, and then we want to check if the output is sorted. So the current simple implementation is just checking if the output vector is an ordered list.
Cool. I like it.
And the improvement is to check if the input values have successfully arrived. I'm not sure if we can improve anything further than this. I don't think so. So checking if it's sorted and checking if the inputs have survived. That should be enough.
Well, yeah, you do want to know some metrics on your inputs though. You don't want your inputs to all be sorted already or be in some. You want a wide variety of inputs, right?
Yep.
So I don't know how you test that. I have to think about it. I haven't really thought about that.
We can select the input size, maybe 32 bits, and then we are generating 64 input values of 32 bits. These are generated randomly and passed into the network.
Yeah. Well, the number of bits isn't important. It's whether the network is correct or not, right?
Yep.
So and I suppose for every major, I don't know how interesting do you have generate blocks in there?
Yeah, 5 nested generate loops.
Oh, yeehaw. So you need something checking the different endpoints of the different number of items in there, right?
Yeah, we can generate the number of inputs. So we have a test bench for a sorting network of size 4, 8, and so on. And so we can discover if we get problems if the sorting network is growing. Because of the nested loops, some failures only happen if the sorting network is greater than 32. This was a problem. And what was another one? We figured something else out. I don't remember yet. So yeah, it's not easy to test such a network.
Yeah.
And it's taking many cycles, even in the simulator, to run many test cases here.
Right.
Okay. Torsten, do you have questions?
Not to the OSVVM presentation because I had attended to the course already. I know. And we use it at work, or I use it in almost all test benches I write. We also include it in. We have a tool which generates some kind of verification frameworks, the teckel scripts and so on for model sim. So and the OSVVM and our self-written simulation libraries included in every test bench. So mostly I use the random package and the coverage package, I think, and the resolution package and the test bench util package. Yeah, the synchronization stuff and so. Yeah, and I think it works good. Yeah.
We had another question regarding the, what was it? Generic associative arrays implementation. You wrote it. Jim asked, what's the status here and
Oh, okay.
what's going on?
Did you get my email?
I didn't.
I got an
No,
email.
I sent one to Patrick.
Oh.
I can forward this.
Yeah, you should forward that on to Torsten.
Okay.
There was one that Peter Ashton, the guy who wrote the generic proposal, actually wrote an associative array implementation.
Okay.
But it was, it's all a white paper thing because it was written before the standard was done.
Okay.
So.
Yeah. My implementation is at the moment you set the init size, and that's a vector, a static vector of pointers to lists of entries, and so at the moment it can't be resized. So if you want dictionary which can be resized on the fly, we have to change the static vector to a list. But I don't know if that's important. Maybe the first shot can be a static list, and then like the current implementation, it would be easier to implement at the moment. And I don't know tool support, maybe a point.
I think to figure out some of that stuff is we ought to be looking at the ADA libraries, because I've seen in the ADA libraries that they seem to have a concept of bounded and unbounded.
Yeah, at the moment I have an I think I bounded.
You have a bounded.
Yeah. If you have more than entries than the init size, more different hashes than the init size gives, you have more than one entry per slot. So the search time isn't static, so it's bigger, increases But if you have an unbounded implementation, the search time is always the same. Yeah. But then you have to resize the slots, number of slots on the fly.
Yeah, I know about resizing.
Yeah.
The scoreboard model and the memory model. Well, the scoreboard model can be dynamically resized.
Okay.
And as
Maybe
long as you're not getting smaller, is lossless.
Maybe I have
I don't have any use models for that, but for some reason I decided to make it that way, and I've tested it that way. The memory model is dynamically sized, but it's static.
Yeah.
Meaning that once you size it, that's it. You don't resize it.
I think that the scoreboard is more like a queue. I think a dynamic list.
Yeah.
Yeah. And you, with the dictionary, you have in a bounded implementation, you have dynamic lists which are pointed from a static list. And if you have an unbounded implementation, you only have one dynamic list which pointed to one entry each. So you have change the complexity from the lists. To this, you only have one list with one entry each. Yeah, maybe I write a second implementation and we can compare maybe, or you can choose it at instance time. I don't know if that makes sense.
As I said, we should look at the use models that Ada has been using, because they've been around for quite a while, and we might be able to glean some insight of to what and why. Yeah, you're right, because the scoreboard model is dynamic. It uses linked lists, and I noticed that Levin had posted that more recent implementations are going away from linked lists.
Okay.
So, or it sounded that for efficiency, from an efficiency standpoint. And, I think from an initial implementation, we don't care about efficiency. We care about functionality first.
Yeah.
Because if we do everything in a protected type, you can always make another protected type that has the identical interface.
Yeah, the most important part is the interface. That's right.
Yes.
And
you got to get the interface right and got to agree on the names and all that. But once you get beyond that,
yeah, maybe then we can add more concurrent implementations and can compare, and then choose one or maybe two implementations for different use cases. Yeah. I'll have a look in the Ada standard library, or is it defined in the language itself?
I'm not sure how. I think like VHDL.
I think they have a namespace called container.
Ah, yeah.
There's something listed under containers, and I found a wiki book. I think the page is called wiki books. They have an Ada book, and there's a sub page for containers, and they are talking about lists and other.
I have the Barnes book, I think, for Ada 2005, and I will have a look. Maybe I think here's a container library, and there are double linked list, maps, sets, sorting, indefinite containers. Maybe here's something about the implementation. And when not, I have to look in the then have to be some code in to CNAT compiler, I think. Maybe I will look.
The string stuff, how different is that from what VHDL would have? Can't we just lift some of this stuff directly from them?
You mean the proposal under helpers, string manipulations?
Yeah, why can't we just swipe Ada packages and convert them to VHDL packages? If it makes sense, is what I'm saying. And
Our string implementation for the POC library is based on fixed size strings. So it's
Well, they have that though, because they have ADA strings bounded and they have ADA strings unbounded. So what you've done is probably based on bounded.
yeah, should be.
Although this page isn't showing anything. I'm obviously on the wrong page. I'm looking at that Wikibooks page.
I'm not sure how to search in a certain book here. Ada programming.
Yeah, this is
Strings. So this looks like the normal strings in VHDL. Yeah, here's something like strings fixed.
Ada Community Libraries actually goes to a public library system. Ada Information Clearinghouse. Oh, how did they end up with that? Rosetta code.
I'm not sure how we can implement unbounded strings. I think we have to use a protected type like you did with your name package to encapsulate the string.
I'd have to see what they have. I'm not. Where are you looking at the code at?
I can paste one of my links into the chat.
Perfect.
So it's a Hangout chat. So you have two sections on bounded and unbounded strings.
I'm just saying, if there's something there that makes sense, then we should steal it. If not, then we should go in our own direction, right?
Yeah.
I'm not
My
saying
use case is that strings have to be functioning in synthesis too. So we are using fixed strings, and unused characters are filled with null. So this is working in synthesis, and we can produce assert messages and so on in the synthesis log. But yes, I can compare them. What's the difference, and if you can implement the unbounded strings.
Yeah, as I said, it's just a matter of whether it makes sense or not.
Yep.
I mean, some things they might have just for historical reasons. They might have been trial and error, and they realized it was an error, and they moved on to something else. So it looks like an error. There's no reason to implement it. There's no reason to implement it if it doesn't deliver value to us. This is not a academic exercise. It's something that's going to return some value. But I just figured if there, what I was thinking is if there's bounded length here, it says bounded length string handling and unbounded length string handling. When I think of bounded length string handling, what I think of, which may be incorrect, is that the length of the string is tick length of the object and exactly matches. When I think of unbounded, I think of that the string actually might be the string value might, the container for the string value might be 80 characters, but then I null terminate it so that I can determine where the end is.
And you have also the fixed length string handling. There are 3 types: fixed, bounded, and unbounded.
Oh,
What's the difference between fixed and bounded? Maybe fixed is like in VHDL and bounded is filled with null characters.
I don't know.
I can. We have some Ada and Spark experts at work. Maybe I can ask them how it works. What's different? Because they do a lot of Ada stuff and write microkernels and so on in it with the language. So they have to know the very lot about string and string handling and something like that. Maybe I can ask them what's the difference, what they use, and what would be possible to transform into VHDL maybe.
Yeah.
That'd be awesome if you could ask them for advice on what would be worthwhile translating and what wouldn't be.
Yeah, but what they mostly use and what other Ada users use maybe is the same as what we have to
Right.
what we use in VHDL maybe.
What they use and why they use it.
Yeah.
Because the why might be something, you know, that Ada does that VHDL doesn't.
Yeah.
Okay.
Maybe I can also ask them about the data types. Yeah, I have to write. I will ask them.
Cool.
So I saw we had got a list of 3 items here for the project goals. Lars also wrote a big
Good
paragraph here. He's not here today, and I think we will delay this for the next meeting.
Okay.
And yeah, so we can talk about it and try to resolve it to one big page, so we can put it on top of the navigation or so. So we can
hopefully get a couple more people.
Yeah, that would be
commenting,
nice.
not just us.
Yep.
But and maybe other people just want to come along for the ride. I don't know, but
I would like to replace this proposed roadmap page here, because most things are already done. The site is running, the repositories
Awesome.
are online.
Okay.
So we get a better introduction page here, and so we can paste it here, so the main goals, and then maybe a sub page to explain the goals in detail.
Yeah.
This is, I think this is the next big step for the page here and for the group to get this running.
You might do something on who should participate and why, because you know, some people, like even in the VHDL standards community, think everybody has to be a power user to be able to do something for the open source group, and that's not, I don't see that as the case. We just have to have also, in addition to power users in this case, we need people who are willing to try things out and point out when it's awkward.
Yeah. Yeah.
You know, I mean, we might have something and we might understand exactly how we want to do it. It might work well for us, but you know, for some folks, they might find it that it's awful, and we want to find that stuff out early.
Maybe
or not intuitive.
If you have the first implementations, maybe we set up bundles or on GitHub, which for different simulators to try. So we can.
But we want to appeal to people who more than just GitHub power users.
Yeah, everyone.
We want to gather more than just the usual suspects. How's that?
Yeah. Another thing on my list is for the proposals. I started some time ago the license page here. I put down the main goals for me, what the license should cover
Ah,
and what it
I'll add to
shouldn't
that.
restrict. So
I'll add to that.
I have started with Martin to draw an image how the Apache license works. So we figured out how the licenses are passed from a writer, from a contributor, and so on to the
that'd be great.
maintainers. So we have a visual what is going on with the license. The last point, what is missing is the German law. In the US case, it's very easy. You have licenses, and the complete copyright is based on licenses. That's not quite possible in Germany because you always stay the owner of a work, and you can't get rid of the ownership. So in the US, you have only licenses. You pass on everything, and yeah.
Oh. Mm-hmm.
And the question is, if you write down copyright by and so on, what do you have to write into this line? Is it open source group, or is it Patrick Lehmann, Martin Zabel, and do you have to name everyone who has contributed one character to the file? And this is a special question for the German law, or maybe for the European law, because it's sometimes working a bit different than the US and UK law. And we have to figure out how we can cope with such an US license like Apache or Mozilla or whatever.
That's
So,
Apache.
Yes. Apache.
Apache. It's like the Native American Indians.
Okay.
They were a tribe.
Okay.
So you got to watch some of the old westerns.
Yeah.
And then you'll learn who Apaches are.
Maybe it's a translation problem. I
Could
don't
be.
think we pronounce it with an E at the end.
You know what? In US English, we often adopt the enunciation of whomever is contributing that piece of language. Right? So some things aren't the way they look like they are. And if you look at city names, there's a lot of that. You know, like there's a city that's spelled looks like it's Woodchester, but it's pronounced Worcester. So, and just like any other country, we have also regionalities where people pronounce the same word different. So, but Apache is always Apache.
Okay. Yeah. Maybe you can write also a paragraph here in this page. Put down your goals for license.
My license goals. So, I mean, one of them is very simple, easy for someone to review.
Yep.
Because that's what's gonna facilitate adoption. If it's not a standard license like Apache, then it needs to be easy to review. And I don't think any of them are really focused on reviewability. They're really focused on this is the license. And, you know, as I mentioned in the other meeting, I really wanted to say something like, if you're just going to do, you know, if you're just going to use the package, it's free, use it. And then modifications and all that kind of stuff, deviations are all governed by this.
And also that it's well known. It should be well known. So the legal department has already reviewed it, and so I don't have to go to them and here's the new project with another license. Maybe I have it. So we have to.
Did you have to have them review the Perl license?
We have a big list of licenses, and they go one after another. And on the end of the list, I have added artistic license of the EOS-VDM project, but it's not too important because it's only verification stuff, not
Right.
stuff which goes to the customer or to the States Department for we work with. So it's only code which lies in our company, so it's not that important. But if you have code which goes into synthesis or to the FPGA, it's more important, I think, for us, because we hand it over to the customer and to the BSI, and that would be better. If it's a license which is well known, so we can ask them, is it okay? And they, oh, Apache, oh, we already know Apache, that's good, or maybe BSD or something like that, or Perl, maybe, I don't know which is more used as, yeah.
So yeah, I think writing down goals for a license here on this page is also a step
Does
for the
Apache
next.
require that modifications are also Apache?
Yes.
So they must be done under the same license.
Yes. Not a must, but if you bring back your modifications to the original repository, you accept it that it's passed under the same license.
Okay.
You could upload a file under another license, and you can state this, and there's a file where you have to write down your file name and say, okay, this is a external contribution with another license. That's possible, but normally every contribution is put under Apache 2.
Yeah. Okay. My other bug that I would like to see in licenses is that modified code that gets distributed is automatically returned to the original folks, but I haven't seen one that requires that. That's why I picked the artistic licenses, because it strongly encourages that, but it doesn't enforce it.
There is one. What's the name? Let me look for it. I've seen one of this.
Yeah. I don't care what you do if you keep it private. But if you want to distribute it and you want something different that has additions to the interface or internal capability, then I want it redistributed to everybody. If you distribute it, yeah.
The license is called GNU Affero General Public License, or AGPL.
Oh,
Affero GNU GPL.
Yeah, anything that says GPL is a non-starter.
Yeah, and this Affero copy of it, and this Affero version has a clause in it that every modification has to be published to the original repository under the same conditions and so on. And you can modify it, but if you do it, even if you don't do it in a public way, you have to distribute it.
Oh, that's what I don't like about GPL. Generally, is too harsh.
Yeah, I think it's a non-starter for hardware designs, because you have some kind of binding. You are compiling your VHDL code for synthesis and so on, and you want to use it in a product.
We have a lot of mil-aero people that can't, that want to update it internally, but can't share it outside.
Yeah,
and we want them to use it.
And this was one of the big points that we started to use Apache.
Yeah.
And it also has no restrictions on the use case, so it's not restricted to non-commercial use or non-military use.
Yeah,
some licenses have such clauses too. And
really,
does Apache require disclosure that you're using Apache licensed code?
Yes, you have to name somewhere in your documentation or wherever that you're using a library from this author, and you have to name it's licensed under Apache. So you are only stating the name of the author and the license name. And you
Is that
can
generally acceptable, do you think, Jim, to customers? Certainly to our company it is.
That
You have to disclose an Apache licensed item in your product.
Oh. Well, OSVVM stuff is mostly verification, so it's never delivered with a product. So I've never really thought about that one.
Right, and I wasn't too worried about the licensing for verification components because they're not released. But for
Right.
example, some of the synthesizable functions might end up in your
Oh, absolutely. I would hope
release.
so.
Yeah, so
I would be insulted if I wrote a RTL library. I'd be insulted if people didn't reuse it. But I wouldn't want them to have to say they reused it. That would be bad.
Right. So that's part of the Apache question I had. So I mean, on the firmware
Yeah,
side,
no, I think that would be bad.
Yeah. Okay.
The reason I think that would be bad is imagine somebody making something like a crypto core, right? They can't tell other people what they're using internally because that gives people some insight in how to crack it.
can you see my screen?
I can. It's awfully small though.
Yes.
I found my
think I
reading
can-
glasses though, so I'm doing better with that stuff.
Sorry, I can't resize this window. It's from Vivado, from Xilinx, and they are stating that's a product, version number, and so on. And you have your about box, and it's saying we are using source code and products from the following companies, and then you get a list of companies,
Yeah.
copyright notes, and license notes, and so on. And if you have an Android phone, you can go into infos also, and you will get a big list of used licenses.
Yeah,
and
but I don't want people to have to list that. I don't think they necessarily should. I mean, it's nice that they would list it, but
for us as a university, it's the own reputation we get. If we can say, okay, we are used in this product, they have listed us, and we can say, yes, our name is out in the world. So
yeah, but as you know, if you get it released as VHDL source, your name's out in the world anyway.
yes.
So, you know, like with OSVVM stuff, when it's released with the vendor tools, they also release source because everybody screams about wanting source. Well, there it is. I don't need anything more. I don't feel like I need anything more than that.
But also the weakest licenses like MIT or BSD, they have a clause that you have to name the product or the author.
Also, like
Yeah.
Apache.
Yes.
The
Apache license is like the big brother of MIT. It has more concrete rules how to handle such things like
Right.
contributions. But the general idea is the same like MID or BSD license. They are in the same family of permissive licenses. But they have special rules like how to cope with patents and so on.
Okay.
Just a quick web search, then one option is there's this thing called the unlicensed, which is essentially public domain. It says, however, you can limit liability.
Yeah.
So yeah, there's the Creative Commons licenses also.
Yeah. The CC0
software licenses, they're generally text licenses. I suppose they can be applied to stuff like that.
Oh, the unlicensed is a public domain notice, basically.
Yeah.
So, but you don't want public domain. You still want to maintain copyright here.
Well, like Patrick said, a document is copyrighted whether you list it copyrighted or not. In the U.S. law, everything you write is copyrighted by you. Now,
sure,
typically,
you don't want to release that. I'm saying.
Yeah, and you need an explicit release in it to release it.
Right, so that's my point. We don't want to just say this is public domain code, use as you see fit.
Well, that's BSD or something like that, right? Isn't that what BSD says?
It's keeping
MIT
the copyright
requires.
to you. the copyright stays still to you. If you do a CC0 or an unlicensed, everybody can overwrite your copyright.
Oh, yeah, they shouldn't overwrite your copyright ever. That's not right.
And this is the case with Apache. You can't overwrite the copyright. It still
Right,
stays in the
but you
file.
shouldn't have to disclose, right?
I can look up how big the disclose is. If you have to
Well,
write it or just if
I
it
just
has
see
to stay
right
in the
here.
file.
In the BSD license, it says redistribution in source form must retain the copyright notice. Redistributions in binary form must reproduce the copyright notice and list the following conditions within the documentation. So even the BSD requires a notice that it's in use.
Yeah.
I don't think you have to say what you're using from the library. You just have to say the library is being used.
But do you have to do a
Specific.
splash screen or something, or?
No. Normally you have a how's it called? There's a file in your structure, like license and contributions. There's I think for Apache it's a notice file, and there you have to list all sub licenses.
Well, so for example, in terms of products, the products we ship that use open source, in our manual, we have a page in the back that says portions of this product include software, just like you just saw on the Vivado splash screen. So it's in our manuals for a hard piece of hardware you buy.
Interesting.
Now, so I assume if you're going to distribute, say, for example, a encrypted net list or something, you'd probably have to include in your documentation for the net list something similar.
All right. Well, we can talk licenses more later.
Can you still see my screen? In Apache, you have the right to say as a copyright owner, it's not a contribution, so you can exclude some contributions from the license. This is one part, and yes, here's the notice text file where you can list sub-licenses and so on. And this is also the way.
It says nothing about binary forms, though.
Sorry, can you repeat it?
It says nothing about binary forms.
Yeah, the Apache license is not about binaries. It's
Okay,
only
so
about
maybe-
source code.
So maybe we are okay in this sense then. So somebody who's developing a crypto core uses functions from CoreLib, and they say they don't have to disclose it when they distribute their binary, say an encrypted net list or a final product.
Yeah. I can look again and in the license here if I found something strange regarding this point, but I think it's one of the most easiest licenses to get your name out if you have source code. And, and I can look for the binary versions, what's happening then.
All right.
Okay.
I'm going to need to sign off here, Pat.
So yes, for the next time, we will finalize the goals and maybe the licenses.
Yeehaw. Now, did you have Espen scheduled sometime, or is he?
I will start the next vote for the next meeting, and
Okay.
I hope he has time.
Okay.
And I'm also asking Olaf if he can present the Fuse SOC project.
Awesome.
So we have another presentation. Okay.
Excellent.
So I will stop the recording here and
Okay.
see you next time.
All right.